In 1991, two hikers stumbled across a body melting out of a glacier in the Italian Alps. At first glance, they assumed it was a recent death. It was not. The man had been lying there for 5,300 years. Scientists named him Ötzi, and when researchers began cataloging what he was carrying when he died, they found something that stopped them cold. Alongside his tools and his weapons, Ötzi was carrying two species of mushrooms threaded onto a leather cord worn around his neck. Researchers confirmed that both species have documented antibacterial properties. A Copper Age man, 5 millennia before the first hospital, had a medical kit. He had chosen those mushrooms deliberately. He had taken them into the mountains. He knew what they were for. That single object reframes the entire question. The question was never whether ancient humans tried to treat sickness. The real question is how much they actually knew. And the answer, written into bones and teeth and burial sites across every continent on Earth, is far more sophisticated than most people ever imagine. Start before Ötzi. Start before modern humans entirely. In 2017, a team of researchers published a study in the journal Nature. They had sequenced ancient DNA extracted from dental plaque, calculus, preserved on the teeth of Neanderthals who died more than 40,000 years ago. One individual from Alps cave in Spain had a dental abscess visible on the jawbone. He also had an intestinal parasite. He was, by any measure, quite sick. But locked inside his dental plaque, the researchers found something extraordinary: traces of poplar. Poplar contains salicylic acid, the active compound in aspirin. He was not eating poplar for nutrition. It is bitter and offers almost no food value. He was eating it because it reduced his pain. A Neanderthal, 40,000 years before we synthesized aspirin, was already using the same active ingredient to manage the same kind of suffering. The researchers also found traces of penicillium mold in his plaque, the same organism that Alexander Fleming would identify in 1928 and turn into the world's first antibiotic. The Neanderthal from Alps was self-medicating with a natural antibiotic more than 40,000 years before modern medicine gave that concept a name. Now move forward to early modern humans. The same pattern of plant-based medicine appears everywhere the archaeological record is willing to look. Excavations dated to 60,000 years ago have found the remains of medicinal plants deliberately preserved alongside human remains: yarrow, chamomile, ephedra. Yarrow reduces inflammation and slows bleeding. Chamomile has proven antimicrobial properties. Ephedra contains ephedrine, the exact compound used today in bronchodilators for asthma. The plants worked. Ancient humans had found the right ones. They did not know the chemistry. They knew the outcomes. And they passed that knowledge down, generation after generation, for tens of thousands of years. Then there is willow bark. Chewed willow bark relieves pain and reduces fever. The Sumerians recorded this on clay tablets 4,000 years ago. The Egyptians used it for inflammation. Hippocrates prescribed it in the 5th century BC. When chemists in the 19th century finally isolated the active compound and refined it into a stable form, they called it aspirin. The drug that modern medicine considers one of its foundational achievements had been sitting inside tree bark for tens of thousands of years. And then there is honey. Cave paintings in Spain dating to 8,000 years ago show humans deliberately harvesting it. Ancient Egyptian records document that of the 900 medical remedies their physicians used, more than 500 included honey. They applied it directly to infected wounds. They were right to. Honey produces hydrogen peroxide as a natural byproduct of its chemistry. It kills bacteria. Its low pH and high sugar concentration prevent microbial growth. Everything Egyptian physicians were doing with honey for wounds, modern wound care has since confirmed, works. They did not understand the mechanism. They had documented the result, which is exactly what medicine is. And then there was surgery. A skull found in France, dating back 7,000 years, had a clean circular hole cut through the bone. The bone had grown back around the edges. The patient survived the procedure. Trepanation, drilling or cutting into the skull, is the oldest known surgery on Earth, and it has been found on every inhabited continent. Independent cultures, separated by thousands of miles of ocean, with no knowledge of each other, all arrived at the same operation. The survival rates in some excavated collections ran as high as 75%. They were not just attempting surgery, they were succeeding. But perhaps the most overlooked part of ancient medicine was not the plants or the surgery, it was the people. Researchers at the University of York, publishing in the journal Quaternary Science Reviews, examined the skeletal remains of more than 30 Neanderthals, showing evidence of serious injury or illness. What they found was that a remarkable proportion of those individuals had survived conditions that should have been fatal: severe fractures, debilitating infections, injuries that would have left them completely unable to care for themselves. The only explanation the evidence supports is that other people looked after them. They were nursed, they were fed, they were kept warm while they recovered. One of the most striking cases came from a prehistoric site in Vietnam. A man buried there had a condition so severe that researchers concluded he could not have fed himself, moved independently, or survived alone for the years the bone evidence suggested he lived. Someone, or a group of people, had cared for him continuously, at significant cost to themselves, for a long time. His name is unknown. What is known is that he was not abandoned. This pattern, communities sustaining their sick members, appears across the archaeological record, from Neanderthals through to early modern humans. And it matters because it means that ancient medicine was never just about individual knowledge of plants or surgery techniques. It was a collective act. The community itself was part of the treatment. Beneath all of this was one more force working in ancient humans' favor: their immune systems. Researchers at the Francis Crick Institute, publishing in 2023, analyzed the genomes of 677 ancient individuals from Stone Age Europe. Hunter-gatherers showed significantly stronger systemic immune responses to the pathogens they encountered than the populations that came after them. Smaller, mobile groups of people constantly exposed to varied environments without the crowded conditions that allow disease to spread explosively had immune systems precisely calibrated for the specific threats they faced. The farming revolution changed all of that. When humans began living in dense settlements alongside domesticated animals, entirely new diseases crossed the species barrier for the first time. Influenza, tuberculosis, smallpox. All of them came from livestock. Hunter-gatherers had never lived that way. Their bodies had never needed to adapt to those pathogens because they had never encountered them before. The ancient humans who came before farming were not weaker. The world they knew had simply changed faster than biology could follow. So here is the complete picture of how ancient humans survived sickness. They observed their environment for hundreds of thousands of years with a precision that took generations to accumulate. They found what worked in plants, in honey, in surgery, and they passed it down. They cared for each other in ways that kept people alive who could not have survived alone. Their immune systems were genuinely adapted to the threats they faced, and they built medical traditions so effective that a significant portion of modern pharmacology sits directly on top of them. A Neanderthal with a toothache reached for the same pain relief you would reach for today. He just had to find it in a tree. They didn't have laboratories. They had time, and they had each other. And across hundreds of thousands of years, that turned out to be enough.